I am Prashant P. being posted TI India Analog Design Contest for 2013. I am from BMS College of Engineering from the Department of Instrumentation. My team members are Rahul Deshpande Gajanan, Shivlingesh William, Swati Nayak, and Pooja R. The project title is Intelligent Low Power ATS. It stands for Automotive Telematics System. Motivation behind this project. Nowadays, sets of automobiles are increasing. Monitoring and tracking devices ship with the vehicles of high price only. It is using much, we decided to design a low-cost and low-power monitoring device which not just tracks the location of the vehicle, but it also tells the interior temperature and speed right from the remote location.
This is the block diagram of ATS. The MSP430-543 first initializes the GSM model. It defines the access point names of the service provider, and later SMS is sent to the GSM model about the IP address and the port number to which it has to connect to the remote server. And right after that, it fetches data from the GPS data. It extracts just the location coordinates from the NMEA string, and then it initializes the four sequence ADC. We are using 4 channel, but for the temperature measurement we are using just 1 channel, and the rest 3 are left for future purposes. And the speed is measured by using tachometer MOC 7811. We have used a logic for this is it takes 11 cycles for execution of this for loop. So we have iterated it 9,909 times because we are using 1 megahertz clock. So we are basically sampling the speed data for 1 second and multiplying it by 60 to get the RPM. And right after that, all these values are displayed locally on the LCD controller, one after the other. And in the remote server, it is created on the LabVIEW. LabVIEW stands for Laboratory Virtual Instrumentation Engineering Workbench. We are creating a TCP/IP listen, and the specified port is being fed to it. So it communicates through this port, and right after that, every string that is received from the GSM model is displayed on the string indicator and is stored with the timestamp. This is the hardware setup. We are using Launchpad to program MSP430 using by-wire protocol. We are using a 7805 for powering both MSP430-5438 as well as GPS. We are using 2 diodes in series to reduce the voltage to 3.6 volts because that is the voltage range of MSP5438. And then we are using one more 7805 to power the MOC 7811 tachometer and SIM300 GSM module and LCD module as well. We are using a 8051 peripheral LCD. This is a thermistor. We are using it to sense the temperature with a series resistor 10 kilo ohm. We are tapping it in the middle of thermistor and series resistor. This is the LabVIEW server. We have to specify the port for communication, and right after that, as soon as the GSM module connects, the response is shown here. All the values that are sent by the GSM module is received here, and it is logged down to this file with the timestamp. And whatever we want to input for future purposes, we have done this. Like if we input here, like if the vehicle is due for service or something, as soon as we enter a service alert here, we will get a response that it has reached the destination here. This is the block diagram or the software that we have written for the server. We have created a TCP listen. It opens the port and starts listening. So basically that forms a server. And this structure is divided into a sender loop and a receiver loop. The sender loop is to send the data from the server end to the device, while the receiver loop is to receive all the data like location, temperature, speed. If there is no error, this part will run, and we are collecting 512 bytes for per iteration of this while loop. This is a while loop, and it lasts for 100 milliseconds, or as soon as it gets 512 bytes. If there is error, we are just forwarding the error and the reference to the TCP close, and right after the TCP close we are handling the error by using a simple error handler that displays the error.
Let's program the MSP 430-5438 using Launchpad. This is our program. Successfully programmed. Now I'm running it. Based on the public IP address which we did, we are sending the same as SMS to my number, that is the one which we are using in the setup. Send. Now I am starting the server by running this VI. Now the system is powered up now, and as soon as the system is initialized, we get a SMS called saying ATS is initialized. Now it is giving it is configuring the network. It is connecting to the remote IP address, the one which we just sent through SMS. The latitude, longitude, and the speed value is displayed locally, and the ADC value as well, and that can be inferred on the server. Here it is coming one after the other in chunks. Now the speed value can be seen. I locally generate a speed by using a DC motor. Now the speed value can be seen. Now if we go to the destination and check for the log file, we will get the log file, and here are the values with the timestamp associated with it.